This video is about performing function operations and composition. We need to start by discussing some domain restrictions because the instructions will always ask you to state any domain restriction or state the domain when you start combining functions together. So we got to review what domain means. Domain is a way of expressing all of the possible values for x in a function. So if you have a function like f of x equals x plus 4, this is just a linear function. All the possible values for x include all real numbers. X can be anything in this function. It is not restricted at all. So when it says write the domain, you can just write domain is all real numbers. I'm not going to make you write it in set builder notation or anything more complicated than that for the sake of this lesson. If you've got any polynomial function, it starts with x to the second power, if it starts with x to the fifth power, any function that's just a polynomial, there are no restrictions on what x can be. It could be positive, it could be negative, it could be a fraction, it could be irrational. There are no restrictions. When you do get restrictions is if you have a function with x in a denominator, because we know that a denominator cannot equal 0 or it will be undefined. So for this one, to write the domain, we want to take our denominator and say that it cannot equal 0, solve that equation for x, and when you write your domain, say that x is going to be all real numbers, comma, x does not equal 5. So you're specifying that it can be everything else other than 5. Gets a little bit more complicated if your denominator has more than one solution that would make it equal 0. So like if it was a quadratic trinomial and you're trying to express the domain here, you're going to need to say that x squared plus 7x plus 12 cannot equal 0. And then solve this for all possible values of x. So you may have to apply your factoring skills, which means x cannot equal -3 or -4, because both would give you 0 on the denominator. So you'll say that the domain is all real numbers, but x cannot equal -3, x cannot equal -4. And then there's another case where you have restriction. It's a little bit more complicated, is if your equation or function has a radical in it. The restriction on radicals is that an even radical, like a square root or a fourth root, can't have a negative underneath it, because that would become imaginary, and that's not real, that's not part of our domain. So when you have a square root in your function, instead of saying that x minus 5 cannot equal 0, you have to say that x minus 5 must be greater than 0, right? Because it has to be positive. It can also equal 0. So when you're writing your domain here, include a greater than or equal sign, then solve for x. This time, x has to be greater than or equal to 5. So when we write our domain, we'll say that x has to be greater than or equal to 5, and that assumes that you know it's all real numbers greater than or equal to 5, so you don't need to put the all reals in front of this. You can if you want. It's not incorrect to say all real numbers such that x is greater than or equal to 5. But you'll often see me just leave it as x is greater than or equal to 5. Does this get slightly more complicated? Of course. Maybe your function has both a radical and a fraction. Well, now we've got to consider two possible restrictions. We've got 2x minus 7 that has to be greater than or equal to 0. And we've got 3x plus 1 that cannot equal 0. Solve both to consider the possibilities for x. This one says that x has to be greater than or equal to 7 over 2 in order for this function to be defined. This one says that x cannot equal -1/3 in order for this function to be defined. Well, x is never going to equal -1/3 if you've already set this as the criteria. Because if x is greater than or equal to 7 over 2, it's definitely positive. It's greater than 3.5. Therefore, it's not going to equal -1/3 anyway. So for the domain, you want to choose the most restrictive one. So x has to be greater than or equal to 7 over 2. And you don't also need to say this because it's included in the domain that we just wrote. Now we can start combining our functions together and answering these questions. So if it says, here's f of x and g of x, perform the function operation, that just means add them together if it says add, subtract if it says subtract, and so on. For this one, I like to write my final answer as f plus g of x. You can put the f plus g in a single parentheses, and then just combine them. These are both x to the 1/2 power, which means they're like terms and we can combine them. 4 plus -9 is -5, x to the 1/2. I do not need to write this as a square root, because if the original question is in rational exponent notation, I can leave it in rational exponent notation. But it does say that I should state the domain. I can't simplify it any more than this. My domain for this, because I know that x to the 1/2 power means square root, is that the x has to be positive or 0. So I'm going to say that the domain is that x has to be greater than or equal to 0. Can't be negative in there, otherwise it becomes imaginary. If you need to visualize this as -5 times the square root of x in order to appreciate that domain, it's fine with me if you convert it to that form to write your domain. But your final answer should be in the same notation that the original question was in. So -5 x to the 1/2, where x has to be greater than or equal to 0. Subtracting them, very similar. Take your f function, which is 4x to the 1/2, subtract -9, and that's like adding. It will be 13x to the 1/2 power. And again, the domain is that x has to be greater than or equal to 0 because it's a square root function. Multiplying and dividing maybe gets a little bit more complicated. I've got a new f of x and g of x function up at the top. When I'm asked to multiply them, I've got f times g. It's like taking 6x and x to the 3/4 and multiplying them. You can show the work if you need to. The rule for exponents is that when you're multiplying two expressions together, you can add their exponents. So +1 plus +3/4. I'm mentally getting a common denominator, which will be 4/4 plus 3/4. So it becomes 6x to the 7/4 power. I don't need to simplify that. I don't need to write it as a radical. I can leave it just like this. Because it's a fourth root, remember your denominator is your root, when you state your domain, you have to say that it's greater than or equal to 0. F divided by x. F divided by g rather of x. We're going to take our f of x function and our g of x function. The rule for this is that we subtract the exponents. So 4/4 minus 3/4 becomes 6x to the 1/4 power. Again, it's an even root. Therefore, we have to say that x is greater than or equal to 0. And then the last possibility is called the composition of functions. Okay? So when you have parentheses like this is called a composition of functions. It means putting one function inside of the other. You would read this as f of g of x. And this one you would read as g of f of x. Okay, and it's called composition. What it means is that you're going to take the inside function and put it into the outer function everywhere that you see a variable. So we've got f on the outside here. The f function is 4x to the -1 power. Notice that I've replaced the x in this function with a big open parentheses because what I'm putting into the f function is the entire g function. So in place of where the variable is in the f function, I'm going to put 5x minus 2. The entire g function goes into the f function where you see x. And then you have to simplify it however you can. So we know that a negative exponent means it becomes the denominator. The 4 has only a positive exponent on it and it can stay at the top. But the whole 5x minus 2 has to become the denominator. We can't write our final answers with a negative exponent. So we've rewritten it as a fraction with 5x minus 2 as the denominator. This is the composition of the functions. And I can state my domain, which is going to be all real numbers. They don't have any square roots here, except for the thing that makes the denominator be 0. So x cannot equal 2/5. And then let's do this composition because it's going to be different. This time I'm putting f inside of the g function. So I'm going to take my g function, where I see x, I'm opening a set of parentheses. And inside those parentheses, I'm going to insert the f function, which was this. And then I can simplify. So I can multiply 5 times 4 here, which is going to be 20, x to the -1 power, minus 2. Then I have to rewrite this as a fraction, because I can't leave my final answer with a negative exponent. If you wanted to combine these, you can, or you can leave your function just like this. I'm going to leave it just like this and specify that the domain is that x cannot equal 0, but it is all other real numbers. And then the last thing you should note is that you can combine functions by actually putting one function inside of itself. So you can do a composition of functions by putting one function inside of itself. This would look like take the f function, set up an open parentheses where you see x, and rewrite the entire f function inside of itself. It looks more complicated than it is. What this amounts to is if we distributed that -1 inside, 4 to the -1 to x to the +1, which means that the 4 that's out front and the x can stay on the top. This 4 goes to the bottom, and then it ends up just equaling x. And there's no domain restriction on that, so the domain is just all real numbers. And then the g of x would equal 5 parentheses minus 2, and inside those parentheses you are rewriting the entire g function again, and then simplifying it, going to distribute that 5, combine any like terms that we can combine, and again this one's just linear, there's no restrictions on that, so the domain is all real numbers. So the tricky part is the simplifying, not the actual combining of the functions. So the composition part is pretty simple. Just put one function inside of itself everywhere that you see x, and then simplify what you have left, stating the domain at the end. And that is all.